Auzubillahi Bismillahirrahmanirrahim. Class 11th Physics. We are discussing projectile motion. Our today's topic is equation of trajectory of a projectile motion. Equation of trajectory of a projectile motion. Let us take in projectile. Let us take any projectile. It is having a velocity, initial velocity u. We have thrown a projectile which is having its certain initial velocity u. Let us resolve this velocity into two components, into two rectangular components, the horizontal component as well as into vertical component. Along horizontal component, it is along horizontal axis, it is u cos theta. Along vertical component, it is u sine of theta. We know that it is our y-axis and it is our x-axis. Okay. Let at any time t, this projectile, let this projectile P be at x, and it is horizontal components are x and vertical components are y, or we can say its horizontal value it is horizontal value is like this much is its horizontal value and this much is its vertical value, and this is its x value and this is its y value. Okay, we can say it is origin. Okay, we have thrown this any projectile, a stone, a ball, or anything, any projectile. Let the projectile makes an angle theta with this ground. This is our ground level. It makes an angle theta with it. It's an angle theta. So it is our vertical component and this is our horizontal component. And this u is it is the velocity of it. Okay. We have resolved this u into two components. It is into u cos theta along x-axis and u sin theta along what? Along y-axis. Okay. Now horizontal motion of this projectile. That is, we can show that is along this axis, and this is our vertical motion. Horizontal motion, it may be uniform, but we can see our this vertical movement. It is sometimes like this. Horizontal is this. It is uniform, but vertical motion sometimes it goes like this. P goes P and then decrease. Here is vertical motion like this. This is maximum height, but horizontal components are same, but the vertical components are not same. They are changing with respect to time. We can see our this horizontal component x is shown by, we know that it is our velocity, so it is a velocity component. It is also a velocity component. So we can see this u cos theta is equal to horizontal component x bata time. That is distance bata time. It is a velocity. It is x bata time. X is horizontal distance and time is the at any time we can take from this position to this position, this is sometime, this position sometime, here to here it is time t, here to here it is t1, t2, t3, t4, but there is a t is always present here. So we can take this, it is equal to u cos of theta is equal to x into this multiplied by t. So we can say u cos theta into t is equal to x, or we can say this t would be x divided by u cos theta. This is our time. This time can be x beta u cos theta. It may be used while deriving the equation of trajectory of a projectile motion. We have found it from the velocity. Our velocity is equal to distance beta time, and we multiplied it, we got x, and we got the time. Time t is equal to x by u cos theta. Now, what would be our vertical component? Our vertical component is this y. Y is equal to this y. We know that y is equal to, it is vertical distance. We were finding the distance by equation of motion as equal to ut plus 1 half of at square. We may use same equation here. Y this equation. Y is equal to vertical displacement. U is vertical distance, vertical velocity, that is u sine theta into this t. But here is 1 plus 1 half of at square. In vertical, while the projectile is moving vertical, there is an action of gravity of an earth. The gravitational pull is towards the earth always. While moving the horizontal distance, no gravitational pull, no effect of gravitational pull. When we this move, here is gravitational pull, some gravitational pull, some gravitational pull, gravitational pull, which decrease its velocity. That means it is plus 1 half of at square. Here would be minus 1 half of gt square. It is a is acceleration, while this is also an acceleration. This is acceleration due to gravity. G is acceleration due to gravity, which decreases this g decreases this vertical component. So this is a vertical distance. It is decreased by this g because due to the attraction of earth, it does not attain much and more height. If there is no gravitational pull of the earth, then we have thrown a projectile. This projectile may move up and up and up. But this gravitational pull does not allow to move up, so it may decrease its distance. So we may use u sine theta into t ut. That is, instead of u, we have u sine theta, because we have resolved this u into two components. Along vertical component there is u sine theta, then u sine theta into t is this t. Instead of plus, why the distance formula, it is distance time relation, distance and acceleration time relation. But here we have this acceleration due to gravity that decreases this distance. So we can get u is equal to u sine theta into t minus 1 half of gt square. We know the value of t. We have already found the value of t in the post when we were discussing horizontal component x. We may use that also. Y is equal to u sine theta into t. Instead of t, what was our t? T was our x by cos theta. We can take x by u cos of theta. X by u cos theta minus 1 half of g into x by u cos of theta cos square. It's t square, so it's square. It is for t, which we have already found. So we can get y is equal to this u, and u may cancel. That sine theta by cos theta, that will be tan theta. So we can get x tan theta. This is x. This sine theta beta cos theta is tan theta. X tan theta. Or we can write here. This we can get y is equal to x tan theta minus 1/2 g into x square divided by this our u square cos square theta. X square u square cos square twice we can see it is, so we got y is equal to x tan theta minus gx square minus gx square divided by twice u square cos square theta. Okay, this is our what? This is our this equation of trajectory of a projectile motion. Equation of trajectory. Y is equal to x. What is this? Y is equal to x tan theta minus g x square divided by twice u square cos square theta. This equation is in first degree in y. Degree of y is equal to 1. Degree in this degree of x is equal to 2. Degree of x is equal to 2. Here degree of x, but we are taking the topmost degree, just like if this 3x square plus 4x, we are saying the degree of this polynomial is 2. If it may be cube, we say degree of this it is cube. 5, we say degree of this polynomial is 5. Okay, here the degree of the x is 2 and the degree of the y is 1. So we get this equation. This is an equation which is first degree in y and second degree in x. So the graph of this such an equation would be like parabolic. Like parabolic. If the equation is in first degree in y and second degree in x, its graph would be this parabolic. We have done it in our 10th class. The equation if the equation is in the second degree, the quadratic equation, if we find its graph, we can say x square whatever, maybe if the equation is for y is equal to x square plus 3x plus 2, if such an equation we can find, if we may find its graph may be parabolic. The graph may be parabolic. So the graph of this projectile is parabolic. Inshallah, we have done this equation of trajectory. This equation is our equation. Sometimes it's asked what is projectile and find the equation of trajectory of a projectile, or sometimes it's called what discuss the graph of a show the graph of a this projectile. Is why is it a parabolic? Or some questions. Thanks. Next topic would be our